All right, so last thing we're going to look at with 3D vectors is a cross product. What's the other kind of product we did that applies to vectors times vectors? Dot product. Okay, so the cross product is a second way to multiply two vectors. And it only applies in 3D. There is no such thing as a cross product in 2D. You can't do it. Okay, and there's some different applications to physics and geometry, and one of them that sometimes we look at, but we're not going to today because of time. Bless you. The application that we look at has to do with torque, like having a lever, pulling down on the lever, and figuring out how much torque it would exert on a rod that's attached to the lever. And what makes it kind of a little bit tricky is if you have a lever that's perfectly straight up and down and you pull down on it, nothing happens. But the more it's turned, the more torque you get. And you get the most torque when it's basically perpendicular to whatever it would be turning. So if this was attached to a rod and it was turning it, you get the most torque when it's horizontal. You get the least amount of torque, or you get no torque when it's like this because you can't turn it by pushing down. You got to have a little bit of an angle to be able to push it down. So the torque is constantly changing. But cross products can help us figure it out. So that's the application that you could do from physics, but we'll hold off on that application. Actually, the first thing I just want to mention is how you write cross product. So the symbol for it looks like this. That's V cross W. Okay, so when you see the X between two vectors, that means they want a cross product. If you see the dot, they want a dot product. Okay, and we can't assume that all the other stuff we know about multiplication works. Like we can't assume that if you switch the order, it works. Bless you. Okay. We know that worked with a dot product. You could switch the order and get the same answer. We'll see if it works with a cross product. All right, so there's a few different ways you can do the cross product depending on what kind of background you have about different other topics. But Terraces Rule is probably the easiest way to do a cross product where you don't really need to know anything else other than just that rule. So this isn't always the fastest or the shortest way, but it requires the least amount of other knowledge to use it. Really, you don't need anything else other than the rule. All right, so we've got two vectors. Okay, each vector has an x, y, and z-axis component. The a, b, and c's would all be numbers, okay, kind of like that. Okay, they'd all be numbers. Okay, and to find the cross product, what we're going to do is set up a matrix. Okay, so a matrix is just a way of organizing the numbers to use this rule. 3 by 3 means 3 rows, 3 columns. Okay. In the first row, okay, rows are horizontal, columns are vertical, just make sure that's clear. In the first row, you put I, J, and K. You just write that down every time for every problem. Okay. And then in row 2, you're going to copy down the numbers that are in the first vector, whatever A1, B1, and C1 are. That's row 2. And then in row 3, you're going to copy down the coefficients from W, A2, B2, and C2. A lot of times when you write a matrix, they put these brackets around it. I'm probably not going to keep putting them. It's not wrong if you do that, if you put them or you don't put them, but somebody who's really, like if you're learning a lot about matrices, you'll see the brackets. But I'm not overly concerned if you put the brackets in. Okay, so any question on just setting up those 3 rows? Okay. So now the next step is you're going to copy columns 1 and 2 to the end. Okay, you're going to make a copy of them. So we're going to take what I just circled, and you're going to copy it to the end. So what that's going to do is create 2 more columns, same number of rows. So the first row would be I, J, K, and then you're copying the first 2 to the end. ij. And you're going to do that all the way down. Okay, don't worry about what's circled in red and blue right now. Okay, got A1, B1, C1, A1, B1. Copy those two. And then we've got A2, B2, C2, and then A2, B2. Right, so everything we've done up until now, we haven't really done any calculations. We're just kind of creating something visual we can look at to do the rule, Terraces rule. If you don't want to create this visual, you don't have to. But I think if you don't create it, you're going to be very confused and you're not going to know what's where. All right, so once you create that, basically we're looking at 6 diagonals. Okay, there's 3 in red and then 3 in blue. From here, it's just arithmetic. We're just going to multiply some things together and then add some things up. So we're going to do the following calculation. We're going to take everything that's on red 1, okay, that's the red diagonal. We're going to multiply it together. And remember, B1 and C2, those are just going to be numbers. So you're going to have a number times I. So you might end up with like 6I, okay, something like that. Okay, and then you're going to take what's on red 2, you're going to multiply that together. That's going to give you something J. And you're going to do the same thing on red 3. You're going to multiply everything together, and you're going to get something K. Right, so you multiply all the red diagonals, and you add them up. The blue diagonals are similar, except you subtract them. So multiply everything that's on blue 1, and I subtracted it. Multiply everything that's on blue 2, and subtract it. And everything that's on blue 3, and subtract it. So it's not a hard calculation. You just have to keep track of when you add and when you subtract. Okay, the diagonals that go down and to the right, you're adding. The diagonals that go up and to the right, you're subtracting. Okay, and once you do that and get the answer, that's the cross product. Okay, so what we'll do is we'll try to do V cross W, and then we'll switch the order and see if it comes out the same. And then I want to see what kind of answer that we get. Okay. Does anybody think they know what you get when you're going to do a cross product? Like when we do a dot product, what do you get for an answer? A number. This is not a number. Anyone think they know what you're going to get? It's going to be a vector, right? Because you're going to have something I plus something j plus something k, and then you're going to have minus something k minus something I minus something j. So you'll have some like terms, but when you combine them together, you're going to have an I, a j, and a k in the answer. So the answer is a vector. They're totally different. Yeah. It's totally, that'd be a totally different answer. The dot product doesn't really have, that I can think of, any direct relation to the cross product, like the answer that you get. Not really. All right, so let's see if we can find cross product between those two vectors. All right, so V cross W. So the first thing, if you're going to use Terraces rule, you really want to set up that visual so you can see the diagonals. At least in my head, I can't really picture what would be where without it. Okay, so what goes in row 1? Yep, put ijk. And then row 2? Yep, 5. And row 3? 1, 2, 3. Yep. And now what do I do with that? Yep, copy the first 2 columns over. So we've got ij, 2, 3, 1, 2. Now if it helps, you can circle things so you can see the calculations. But we're going to start with that one, and that one. Those are your, when you circle a diagonal, it has to have 3 numbers in it. Okay, so if you start at the wrong spot, you would know you made a mistake because it would only have 2 in it. So you've got to have 3. Okay, so we're going to multiply everything on those diagonals and add them up. Okay, what do you get on the first diagonal? 9i. The second one? And 4k. Okay, so that's the first half. And now we do the second half, and that's it. So we're going to take this, that one, and that one. And what are we going to do with the 3 in blue? Subtract them. So we just have to remember to subtract. So, and if you multiply them and you get a negative, then it could turn into addition. Okay, so you might be subtracting a negative. That can happen. Right, but let's do this. So what do we get when we multiply 3k and we're subtracting it? And we're going to subtract that and minus 6j. Okay, so now just combine the like terms. What's 9i minus 10i? Negative I. 5j minus 6j. And 4k minus 3k. Okay. They don't have to come out to ones in front. That's just the way the arithmetic worked out. So that is the answer for V cross W. Okay. Any question on that? Right, so how about W cross V? You think it's going to be different? So most of the time when you do multiplication, you can switch the order and you get the same answer. Right? That works with dot product, and that works with regular numbers. 5 times 6, 6 times 5, same thing. So we did V cross W, let's do W cross V. So we've got ijk. What's going to be 1, 2, 3 is going to be here. And then 2, 3, 5. So for people who think it's going to be different, does anybody already think they know what the answer will be? No. Once you do this one, you'll never have to do this again. If you know V cross W, you already know W cross V.
It's going to be the inverse, or the opposite.
The opposite?
Operations will be the opposite. So like it would be positive I plus J minus K.
All right, well, let's do it and see if that's what happens. So I'm going to copy the columns over. Kind of helps if you write it neatly, because if you start to get a little messy and things aren't arranged, then your diagonals might not be as easy to see. So we've got this one, and that one, and we're going to subtract that, and that. Okay. So what do we get when we do the red diagonals? 10i, 6j, 3k, and now the blue. I'm going to subtract the 4k and minus 5j. Okay, what's 10i take away 9i? And then 6j minus 5j, and 3k minus 4k. So that's what actually happened. So when you switch the order, you don't get the same answer. You get a different vector. What's the relationship between these two vectors? The two that I just checked off are not perpendicular, but I'll come back to that.
Yeah, that works.
What are they?
You said conjugates.
I'm not sure, they don't really use the word conjugates with vectors that I know of. But it's the idea of all the signs have changed. Yeah, they're opposites. And if you found the dot product, okay, you would have, I'm just showing you that they're not perpendicular. This would be 1 times negative 1. Okay, that would be negative 1. 1 times negative 1 again.
And negative 1 again.
And then negative 1 again. So that doesn't come out to 0. So that's why they're not perpendicular. There is a special, yeah, they are opposite sides. Okay? And that's all I'll say for now. Right, so any questions on how to find V cross W or W cross V if you already know one of them? Okay, you just change all the signs. So what that means is the two vectors have exactly the same magnitude, but they point in opposite directions. So vectors that point exactly opposite directions are what? They're parallel. So V cross W and W cross V are parallel. Okay, so same magnitude, opposite directions. Now, what I want to do is look at something else. Okay, somebody mentioned something about perpendicular, and I said I'd come back to that. I want to take what we got for V cross W, and I want to see what the angle is with the cross product and the original vector. Okay, I want to look at that angle. Okay, let's do the dot product of V cross W and W. Okay. First of all, does that make sense with just what I'm plugging into the dot product? Because what's V cross W? And what is that thing in general? That's called a what? That's a vector. And W is a vector. And you can do a dot product with a vector and a vector. Right? So that notation should make sense.
Cross product first and then do the dot product.
Yeah, so we've already got the cross product. That's what we did. And now I'm going to find the dot product between that answer and the original vector. And I'll also do it with the other one. Right. So let's do V cross W, which I put right there. What's I times, or what's 1 times negative 1? Negative 1.
Negative
2 times negative 1. And 3 times 1. So what's the dot product? 0. So what does that mean? The cross product is perpendicular at least to one of the original vectors. Let's check the second one. So what's 2 times negative 1? And 3 times negative 1? And 5 times 1. And what's the dot product there? 0. So what that shows us is that the vector that you get from doing the cross product is perpendicular or orthogonal to each of the original vectors. Always, yep. So anytime you take two vectors and find a cross product, the answer that you get is perpendicular to the two original. Okay, so one way you could use that with like a guidance system is if you knew where the ground was, right? If you had two vectors that were in the plane of the ground, you could figure out which way is up. So the plane could figure out, if you're trying to fly, all right, I got two vectors that represent the plane of the ground. I can find the cross product between them, and that'll give me a vector perpendicular up. If you find the cross product the other way, you get exactly the same vector but pointing down instead of up. That's the difference. So any question on that? Okay, so that the application, which I said we're not going to get into really too much here, but I just wanted to show it to you, is imagine that there's a rod, okay, going right through that lever. So what you do is you grab the lever and you pull down on it, okay, you're pulling straight down, and it's going to turn the rod that's going through the end of that lever. Well, if you're pulling straight down, you're pulling down perpendicular to the rod. So the fact that you're applying a force perpendicular, you'd be able to use a cross product to figure out how much torque you're exerting on that rod. Great, and the torque does depend on a couple things. First of all, the longer your lever, the more torque you exert. That's why sometimes you see like 18-wheelers, if they're trying to take the lug nuts off the tire, they don't use a little wrench this big, to try to get it off. They might use like a lever that's a foot or 2 feet long to get a lot of torque on what they're trying to take off. Okay. And the other thing that affects the torque is the angle. Like I said, if I have a lever that's up and down and I push down, I'm not putting any torque on it. But if I put it this way and now I start horizontal and I start to bend it, now I'm getting a lot more torque than if it was like this. All right. So that's one of the applications you could use a cross product for. And you might study that in calculus. Vectors are definitely used in calculus, and I think that's from the calculus book you'll use next year. Okay, but I'm going to hold off on doing that one. Okay, so any questions on cross product? All right, so I think you guys have already done the first part of that. Okay, there's one homework problem to try. Just try, we didn't do the lever problem. Just take those two vectors and find the cross product. Okay, so find V cross W and then W cross V. And really, if you find V cross W, you already have W cross V. Right? So by the time I stop the video, you probably could have the homework done. Maybe. It's not a very long homework. So what I'll do with the rest of the time, you've got about 50 minutes. Okay, so I'll give you the rest of the time to start the test. Okay, if you're not going to be here tomorrow, I'll give you the second part, and you can start that. And we'll go from there. Okay? Also, I will be after school. If you don't finish and you can't come tomorrow to finish, you can come after school today.